Hi everyone. So for the first circuit, we're gonna build this circuit. So this is uh, a circuit for finding the internal resistance of this panel meter that we have. And so for this, we need 100k ohm resistance, 100 microammeter. It says 100 microammeter, but we only have a 50 microammeter, and then we're gonna use a potentiometer. All right, and so let me first, before going to the circuit, tell you about the potentiometer. So there are two potentiometer in your kit. So one of them is larger, the other one is smaller. So I recommend you to use the smaller one because this is more precise. As I worked through it, I got to know that it's more precise. So it has three different legs, right? If you invert it upside down, it has three different legs. So two of these legs coincide with each other, and this leg stands alone, right? The third leg is in the middle of both of these legs, which is not collinear with other two. So this leg, which stands alone, is the it's the variable resistance arm, and these two legs are the fixed resistance arms. So we should definitely use this variable resistance leg, the leg that does not stand together, and use any of the other two legs. All right, and so for an example, if I choose to use this one and this one, so I need to measure my resistance using my digital multimeter for these two legs and ignore this. All right, so that is better explained in the picture that I just showed. So I recommend you to look at that. So okay, so going to the circuit. So this is my 100k ohm resistance. Okay, so with my 100k ohm resistance, it's coming out from the positive of the power supply, right? It's coming out from positive of power supply. Other leg is going here, where positive of my panel meter is going. I've used a wire to connect the positive of my panel meter, and here a negative of my panel meter is going, right? And this should be grounded, right? This is my panel meter. Again, 100k is coming from positive of the power supply. One of the leg is coming here, and to that leg, positive of my panel meter is connected, and the negative is here, which should be grounded. So I've used this yellow wire to ground my panel meter, right? So this one here goes to the ground here. So next up, we need to connect our Labrador to our PC, right? So when I connect my Labrador to my PC and it's initially supplying 4.5 volts, then if you look at the panel meter, it's giving you full scale deflection, which is at 50, right? So we need to now connect the potentiometer and turn its dial so that we can decrease this full scale deflection to the half scale deflection. So next up, I need to connect this potentiometer, right? So I'll place it somewhere here. All right, that's arbitrary. You can put it anywhere. So I put it here. So remember, this is the middle pin, and as for the circuit, it should go to the positive of the panel meter. The middle pin should go to the positive of the panel meter, and this, I'm using the right pin, so right pin should be grounded. So let me place it this way. So I'll grab a wire. So now I'll use a wire here. So this is the middle, right? Be careful. So where did you connect the middle? Be careful about that. So that row is the middle pin. So I've connected a middle here, a wire here, which should go to the positive of the panel meter right here, right? And I'm using a right pin, so which is here. So now I'm connecting it to the place where it is grounded, so right here, right? So now it is showing me around 20 because I don't know what the resistance it is at. So now what I need to do is I need to change the dial of this potentiometer. I need to turn the dial of this potentiometer so that it shows me 25 microamps, right? So use anything like a screwdriver or something, or anything that you get. I got this metal piece, so I'll use this to turn this dial to bring about exactly the half scale deflection. So just about there. So now, since we've got a half scale deflection, now we need to measure at what resistance that the potentiometer was providing we got the half scale deflection, right? So I'll take my potentiometer out. So I use this pin and this one, right? So I'll measure the resistance across it. So I'll use my digital multimeter, make it point towards 2000 here in the ohm meter section, and then use my probes. So my probes have been out, so I'm just using these wires. These are my probes, and I'll touch this. So you need to properly touch them. While doing that, I got 1926. Alright, so note that value down. So this is my second circuit. So it may look somehow busy, but once I explain you this, you guys will totally understand. Alright, so what's happening here is this is a 47 ohm resistance. Alright, this is my first 47 ohm resistance, which is coming out of the power supply here. The positive of the power supply, it goes here, and to this leg another 47 ohm resistance is being connected here, which comes here, right? And then we need our digital multimeter in series with it. So I've taken out two wires here, this white and this wire here, this wire, these two wires, and I've connected my red probe of my multimeter and my black probe of my multimeter here. Okay, so here now I have connected one of the leg of this 1.5 ohm resistance. So this is going here, right here in the same row. Alright, and also there I've connected 1k ohm resistance here. Why 1k? Because again, 2 times 1498 minus the internal resistance, that is around 2000, gives us around 1k, right? So again, to where the negative of our digital multimeter is going, I've connected one of the pin of 1.5 ohm resistance, one of the pin of 1k ohm resistance. So that 1k ohm resistance is coming here, and in that same row a positive of my panel mirror is going. Alright, positive of my panel mirror is going, and my negative of my panel mirror is going to the other leg of this 1.5 ohm resistance, as you can see in the figure itself. Alright, now this point is essentially grounded because it's connected to the negative part of the power supply, right? So I've used this yellow wire to connect it to the ground. So now I will increase my PSU voltage to somewhere around 9.5 so that I get around full scale deflection here. Do not try to make it exactly 50 because when very large current flows through your circuit, then your Labrador might turn off. That's what happened with me. So I adjusted it around 48, and that's okay. Alright, so at around 9.5 volts I got around full scale deflection. Alright, so like this, my Labrador just turned off because it was providing high. So with everything set up as required, at 9.95 volts I get almost a half scale deflection. I cannot make it go up to full 50 because as we saw, it just turns off due to high current. So this is pretty okay. And at this point I get 98.8 or 99 milliamps in my digital multimeter. It needs to be pointing towards ampere 200 amp. Alright, so now what I want to do is, now I will decrease this voltage to bring about, look, here we go, we have a full scale deflection. Alright, so at this point we get 99, right? So we need to decrease the voltage so that we get 3/4 of the full scale deflection, which is 37.5, right? So I decrease my voltage to bring it around here, which is around 3/4, right? So at this point I record 76.4. So I want to do similar for half scale deflection. Alright, where I record 56. So now I cannot go beyond this point because our Labrador can go only up to 4.5 volts minimum, and that won't let us go down to 1/4 of the deflection. So that is okay, up to half deflection is okay. So that completes your table 1 ammeter circuit. Okay, so let me explain my figure 3. Alright, so let's start from here. This is my 2.2 k ohm resistor, the first 2.2 k ohm resistance. It's coming out of positive of my power supply. It's coming here, right? And right in that row, another leg of 2.2k, another 2.2k ohm resistor is being connected, right? And let it be somewhere here. Then what I did is I used a wire here to bring it here. So I mean, I am just transferring this point here. So I'm using a wire here to connect. This is my 100k ohm resistance. So I'm using a wire here to bring it here to connect 100k ohm resistance here, and let the 100k ohm resistance other leg be here. So this leg of 100k ohm resistance should go to the positive of your panel mirror. Alright, now the negative of your panel mirror should go here, where the this leg of this 2.2k ohm resistor is going. It's right here, right? So in between this I need my multimeter, right? So the positive of my multimeter, the positive red probe of my multimeter is going here in the same row where two different 2.2k ohm resistors are being connected, right? This is my red probe. I'm using a wire to connect it here. Similarly, my black probe is going here, where this 2.2k ohm resistors other leg and the negative of this panel mirror is being connected. Then this part needs to be grounded. If you look at the picture carefully, this part needs to be grounded. That is why I'm using a yellow wire here to ground it right there. Right? It's been grounded here. So that's my full circuit. Again, I'll explain it again. So this is the first 2.2k ohm resistor. It's coming out of positive. It's coming here. Another 2.2k ohm resistor is being connected here. It's coming here. And at the same row where these two different 2.2k ohm resistor is being connected, I am connecting my positive, the red probe of my digital multimeter here, and the negative of my digital multimeter here, where this leg of the 2.2k ohm resistor is being connected. Now I'm using this wire to connect 100k ohm resistance. This is 100k ohm resistor here, and to the other leg of this 100k ohm resistor I'm connecting the positive side of the panel mirror. The negative side of the panel mirror is again going to the same row where this 2.2k ohm resistors and one leg is going, and the negative of the digital multimeter is going. Alright, So this whole negative points, this row should be grounded. So I'm using a yellow wire to ground it here. Okay. So now, what it wants us to do is, it wants us to make the Aspatec Labrador power supply 10 volts. So I made it 10 volts. So at 10 volts, my I've got a full scale deflection here, right? I've got a full scale deflection, and at the same time, my digital multimeter should be pointing towards the voltage measurement section at 20. All right. So while doing that, I get 4.84 voltage. I'll note this down in table 2. So that is, in table 2, DVM is, I got 4.85, and I'll tell you how to write the constructed part. So for now, unloaded part, it wants you to take this 100k ohm resistor out. This is my 100k ohm resistor out. I'll take this one out. And now see here in the digital multimeter, it's 4.91 now. So in the unloaded part, it should be 4.91. Alright. So the last part, the figure 5, is rather simple. Alright, so what I'm doing here is, I'm bringing a wire from positive of the power supply here, and this is this empty space between this wire and this resistance is your RX, as seen in your figure 5. Alright, so this is where I'm gonna insert different resistances to extract currents. This is a 1.5k ohm resistance. This is 10k ohm resistance. They are going at the same, in the same row here, right? And to this other leg of the 10k ohm resistance, positive of my digital multimeter is going, and the negative of my digital multimeter is, I'm grounding it. If you look at the figure 5, it's the negative of the digital multimeter is going to the negative of the voltage source, which is ground, right? So that's it, the circuit is done. So now we need to insert different resistances here so that we can record our current in our multimeter. Right now it just shows 0, and remember, you should make it point towards the ampere, 20 millis. Alright, so right now it's showing 0 because our circuit is incomplete, right? So here we have not put anything. So now I'll grab a 1.5 ohm resistor here and insert it right one of the leg here and the other leg right here. Okay, now I'll look at the current. It's 0.86. So that's in millis. All right, so I'll note that down. So now I'll take this one out, and just the way this one is connected here, I'll connect 3 more different resistances and record the current here in my digital multimeter. That's what we need to do for figure 5.